As we begin extending our knowledge with exponents, I would like to review some of the things that we've already learned, possibly in 7th or 8th grade, or maybe your pre-algebra class. And we're going to do that by just talking about our exponents. So with our exponents, should have learned up until now that if we have something along the lines of 5 to the third power, we should know that the 5 represents our base, and then the 3 represents the exponent. And then it is a repeated multiplication. Okay, so the repeated multiplication of the same number by itself can be expressed as that power. And of course, that power has a base and an exponent. And the expanded form, if we were to look at that, would simply be 5 times 5 times 5, which is 5 to the third power. That is what you should know up until now. That should have been, we're just refreshing what we've already learned. So as we go in and we go to expand our knowledge on exponents, we're going to talk about the 0 and the negative exponents. And we know that positive exponents are a notation for repeated multiplication, but we're going to learn here and we're going to start to understand that a negative exponent is going to be the notation for repeated division. And that is going to go into some of our definitions. So again, we already are familiar with multiplication portions of the exponent, but now we're going to use that negative and go into that understanding. So using the simplifying powers, and negative exponents again are used to represent the reciprocal of a power, but we're going to talk about this 0 exponent real quick, and we can learn that if we know that x to the 0 power is 1, 2 to the 0 power is going to be 1, and even 1,000,000 to the 0 power is going to be 1, because anything to the 0 power is the value of 1. You can put a number into the calculator with the 0 exponent and it will give you a 1. Variables, on the other hand, we can't put into the calculator to get that result, but if we understand the property that any number with a power of 1 or a power of 0 is going to be equal to 1, and that's the using your 0 as an exponent. So if we look at our first examples here, if we go down to B, it says, what is a simplified form of each expression? Well, B, we have negative 5 to the 0 power, and that is going to be equal to 1, because anything to the 0 power is equal to 1. And we'll do some more examples along the way as we get a little bit more complicated. But if I'm going to go over here and we're going to do A, and then we'll continue on, but we're going to talk about these negative exponents. So if I were to rewrite A, that would be 4 to the negative 4 over 1, because any number can be expressed over 1. And negative exponents are going to be the reciprocal in order to be, would be a positive. So I could rewrite this as 1 over 4 to the positive 4 exponent. And then in doing that, I would be able to simplify, of course, without a calculator, because I just don't want to put 4 to the negative 4 in a calculator. Let's see here. 4 times 4 is 16, times 4 is, I don't know, times 4. Let me check here. So 4 times 4 times 4 times 4 is going to end up giving me 1 over 256. So there you go. There we simplified that expression. And then looking over at C, if we have 3 to the negative 2 power, we can rewrite that as 1 over 3 to the positive 2 power, which we know is going to be 1 over 9. So again, I'm just using my reciprocal to make my positive exponent. And I like to say that anytime you move a base over the fraction bar, the exponent is going to change signs. It is going to become the opposite. So as we continue here, we have 6 to the negative 1 power. So we can rewrite that as 6 to the negative 1 power over 1, which is going to be the same as 1 over 6 to the first, or just 1/6. And then E, I will tell you that E can be challenging for some because we often depend on the calculator and we put it in the calculator incorrectly. But without using the calculator, I could rewrite this as 1 over negative 4 to the positive 2 exponent. And then, of course, that would be the same as 1 over negative 4 times negative 4, which we know is 1 over 16. Easy enough, but the problem that we encounter, and I've tried to express this to my students over and over again, is the calculator. When we depend on the calculator, depends on how we put something into the calculator will depend on the answer that we get from the calculator. Because the calculator doesn't know what we're thinking, it only knows what we type in. So this, if I place this first expression into the calculator is going to give me a positive 16. This in the calculator is going to give me a negative 16. And this in the calculator is going to give me a negative 16. And it is because the calculator does the order of operations in the way that you type it in. This calculator, when it processes this, it knows that we are taking the entire negative 4, what's in the parentheses, and multiplying it times itself to get a positive 16. But if we don't use parentheses, the calculator will process this portion of the equation is negative 1 times 4 squared. Well, in the order of operations, it's going to square that 4 first, which would give me a positive 16, and then a positive 16 times a negative 1 is going to give me negative 16. So understand that that's what's going on here. Same with this third example, we're going to have negative 1 times 4 squared, and it's doing these same operations. It's doing my exponents first, which gives me a positive 16, and there you go, you get a negative 16. So it depends on what you want the calculator to do, and what you type into the calculator are sometimes different. So please be aware of that negative 4 times negative 4 is a positive. Negative times negative is going to give me a positive, but if you put it in the calculator wrong and you depend on that calculator, you're going to get it wrong. So just be careful that sometimes we take for granted some of the very easy things. I don't like to be calculator stupid, and that's just because I put something in the calculator wrong and it gave me the wrong answer. All right, so simplifying exponential expressions here. What is the simplified form of this expression? Well, we're using variables now instead of numbers. So I know that, again, anything can be written as over 1, and then I would find the reciprocal to make that a positive exponent. So in A there, I should have 1 over x to the 9th. There's my reciprocal. Now, to do the same thing, I'm going to find the reciprocal of this, and the reciprocal of B is 1 over n to the negative 3. The reciprocal of that is going to be n to the positive 3 over 1. Or we can just simply say n to the third. Looking at C, I think one way to do this is go ahead and separate. We know that some of the stuff that we know that's going on in C here is 4c to the negative third b, which we know that, hey, there's multiplication going on there. We just don't have the sign because it's not necessary. It's understood. So here we would have 4 over 1 times c to the negative third over 1 times b to the first over 1, and I guess I forgot to put 4 to the first there. When we're simplifying, we're trying to get rid of these negative exponents because we want to have positive exponents when simplifying. So right here, I have a positive exponent for my 4 and my b. So I don't need to do anything with those. But I do need to find the reciprocal of the c to the negative third in order to make it a positive. So when I rewrite that, I'm going to have 4b are going to remain in the numerator because they're already positive. But the reciprocal of c to the negative third is going to be 1 over c to the third. So I put that over the fraction bar, and there you go. We have our simplified expression with positive exponents. And sometimes breaking them apart is the easiest way to see this, and I know a lot of my students will hate fractions. But, we got to embrace the F word, fraction, and work with it. So as I break D apart, I'm going to have 2 over 1 times 1 over a to negative 3, negative third. So I know that my 2 has a positive exponent of 1, so I don't need to do anything with that. But in order to simplify my variable, I'm going to need to find the reciprocal, which is going to be a to the positive third over 1. So now I have positive exponents, and I can just rewrite that expression, and you can rewrite it as 2a to the third over 1, or, of course, anything is understood to be over 1, and there you go. We have 2a to the third is that simplified expression. And doing the same here with e. All right, so I have n to the negative fifth over 1 times 1 over m squared. And m squared, that's a positive exponent already. I don't need to do anything with that, but I do need to find the reciprocal of the negative 5. So that is going to become 1 over n to the positive 5 times 1 over m squared. And all I need to do is bring that into one expression, and I have 1 over n to the fifth m to the second. And the commutative property of multiplication, order doesn't matter, so some students might end up coming up with this, which is the same answer, just a different order. And our properties allow us to do that. Evaluating exponential expressions. Well, evaluating an expression is the same as it's always been. We take a value that they've given us and we substitute it in for a variable and then find the mathematical result. So it says, what is the value of each expression for n equals negative 2 and w equals 5? Well, here we go. I have an n and I have a w, and they've told me what n is supposed to be, and they've told me what w is supposed to be. So I can replace those values, and I know that I have negative 2 to the negative fourth times 5 to the 0, and I know that this is going to be 1, because we know that anything raised to the 0 power is 1. And the reciprocal of negative 2 to the negative fourth power is going to be 1 over negative 2 to the fourth power. And that is going to end up being 1 over 16 when I simplify that. Negative 2 times negative 2 times negative 2 times negative 2 is going to give me a positive 16. Continuing on here, do some substitution. I have n, which is negative 2 to the negative 1 power over 5 to the 5 squared, or 5 to the second power, and that is going to be, if I rewrite it here without a calculator, I'm going to have 1 over negative 2 to the positive 1 power times 1 over 5 squared. And here's where a lot of my students will make a common mistake. We have negative 2 to the first power times 5 squared. A lot of students may turn around and say, oh, I need to multiply negative 2 times 5 and then square it. That is not the case. We need to make sure that we are following our order of operations, which is exponents first. So I would have 1 over negative 2 times 25, because 5 squared is 25, and that is going to give me then 1 over negative 50. So that's a common mistake that I encounter with my students, doing the incorrect order of operations. Continuing on here, we have n to the 0 power, and we could substitute negative 2 into the 0 power, but we should be getting to the point that we know that is equal to 1. So technically I have 1 over w to the 6th power, and then 1 over, when I substitute in 5 for w to the 6th power, I believe that is going to turn out to be 1 over 15,625, if I remember correctly from class. That is the value that we came up with. And then finally, this last expression. So simplify. Let's see. I'm going to break this up. And we know that there is multiplication going on here. So it's going to be 1 over n times 1 over w to the negative 1. And simplifying, I know if I'm going to go with a positive exponent, I could say, hey, I got 1 over n times w to the first over 1. Find the reciprocal to make it a positive exponent. And I know that I could rewrite then as w over n. And I know then when I do my simplification, that becomes 5 over negative 2. There we go. And there, it's just that simple sometimes. Okay? So did my substitution, and moving on to the next, let's see here. Using an exponential expression. So it reads, a population of insects triples every week. The number of insects is modeled by this expression. And it says where W is the number of weeks after the population was measured, evaluate the expression for W is -2, W is 0, and W is 1. What does each value of the expression represent in the situation? Okay, so let's do the first part. Let's go ahead and do our evaluation right here. And when I go ahead and put in W is equal to -2, I've replaced it in my equation that they provided me. So I have 5,400 times 3 to the -2 power. And I'm going to go ahead and just simplify this and express it in a positive exponent. So that would give me 5,400 times 1 over 3 to the positive 2, which simplifies to 5,400 times 1 over 9, which when I do the multiplication, it becomes 600. Now let's do the next. So simplifying for W equals 0, I take my equation again, and I have 5,400 times 3 to the 0 power, which equals 5,400 times 1, because anything to the 0 power is 1. And then therefore that simplifies to 5,400. And then finally, when I take and I evaluate it for W is equal to 1, I have 5,400 times 3 to the first power. That is going to simplify to 5,400 times 3, which is equal to 16,200. So there we've found our values. That was easy enough, our 3 values. But then it says, what does each value in the expression represent in the situation? Well, if I say these insects are grasshoppers, I should see here 0, as some of my students were able to tell me today, which was great. 0 represents my y-intercept. That's that starting point, the initial value. That's right now. And right now I have 5,400 grasshoppers. Okay, so if I have 5,400 grasshoppers right now, well, 2 weeks ago, we started off with 600 grasshoppers, because that is -2. So I'm going to back up 2 weeks. 2 weeks prior to now, we had 600. And then we're expecting next week, after 1 week has elapsed, because W is 1, we're expecting to have 16,200. So again, this is, we have -2, we have 0, and we have 1 week in the future. And that's the context of what we are calculating. Okay, so extending what we talked about at the beginning of this lesson, 0 exponents. Any number to the exponent of 0 is going to be equal to 1. So anything to raise to the exponent of 0 is equal to 1. And then also, as we talk about our negative exponents, we know that a number to a negative exponent is the reciprocal of the base of the positive exponent. So if we have a to the -c, that is going to be equal to 1 over a to the positive c. There's my reciprocal. And an example, if we have 5 to the -2, that is equal to 1 over 5 to the positive 2, which we know is equal to 1 over 25. So again, going into some of these examples and expanding on some of the knowledge that we already have in exponents.